Happy National Numeracy Day!
Welcome to National Numeracy Day Live.
I'm Bobby Seagull.
And I'm Jessica Gagin.
Good morning to all of the children, nurseries, schools and families joining us today from across the UK. It's great to be here at William Davis Primary School in East London. We're also joined by a very special friend today. Let's go over to our fellow ambassador and Strictly Come Dancing champion, Katia Jones, to find out more.
Thank you, Bobby. Hello, everyone, and happy National Numeracy Day. Thank you for the lovely introduction, but I am also joined by a special guest. Say hello to my friend, Numberblock 1. Hey! It's great to have you all here and you. In a minute, we'll kick off National Numeracy Day with my special National Numeracy Day dance. It will get us all feeling full of beans ahead of a day filled with fun activities. After that, we'll find out all about numbers in space. Bobby and Jess, it sounds epic. Please tell us more about it.
Yes, we'll be having a chat about the wonders of numbers in space. We'd love for you here at William Davis School and wherever you're watching, online, in your class or home, to ask us your numbers in space questions. So get your thinking caps, or should I say, space helmets on.
You can share your questions with us using the live chat function on Zoom or in the comments section if you're joining us via YouTube. When you leave your question for us, please let us know which school, town or city you're joining us from today.
But now, it's time for Katia to get us all warmed up. So, find a space and get ready to dance.
Oh, they are keen, they are up. Okay, we are going to show you what maths and dancing have in common. Just like numbers, if we break things down and take it slowly, we can do anything, guys. Is that right? Yeah! Exactly. Okay, I'm going to break it down. Follow me along, and you will be able to do this routine at the end of our warm-up. Right, we're going to start on this side. Find your foot. And we've got a heel and a toe, and a heel and a toe. And we march to one side. Numberblock 1, you're doing great. Let's repeat it on the other side. And a heel and a toe, and a heel and a toe. Take it to the other side. Very good. Now, we're going to do a little lasso move and slap our knees. But I want to hear you go, yee-haw! Slap your knees. Let's do it together and yee-haw! Slap your knees. One more time. Yee-haw! Slap your knees. Amazing enthusiasm behind me. From there, we're going to put our hands on our knees and go in and out, in and out, in and out, in and out 4 times. Shall we count that together? Let's go. 1, 3, 4. Repeat. 1, 2, 3, 4. Very nice. Now we're going to find our airplane wings. Jess knows all about that. And we will be tapping our foot behind twice. Tap. And same foot in front of us. Tap your foot. Tap your foot. Let's repeat that. Behind us. Once. Twice. In front. Once. Twice. Very good, guys. You're great airplane wings. Right, we're finishing it off with a count of 5. We're going to have 4 strong lassos above our head. A 1, a 2, and 3, and 4. And on a 5, you can hit any position that you want. I'm going to go for 5. Okay, and we can count it all together. Are you ready to count to 5? Yeah. Let's go. And a 1, 2, 3, 4, 5. I want to hear that louder. And again. A 1, 2, 3, 4, 5. Very good. Now this is it. This is our entire warm-up routine. I think we're ready for music. What do you say, Numberblock? Yes, we are. We're going to start slow and steady with a level 1 and then build our confidence as we speed the music up. William Davis School, are you ready? Yeah! Let's go, level 1. Here we go. And heel, toe, march to the side. Heel, toe, to the other side. And yee-ha, slap your knees. Yee-ha, slap your knees. In, out, in, out, in, out. Airplane wings. Tap, tap, tap. Now 5 counts. 1, 2, 3, 4, 5. Wow, that was phenomenal. Great start. Now I'm ready to speed things up. Level 2, let's go. Hands on your hips. Here we go. And heel, toe, march to the side. Heel, toe, to the other side. And yee-ha, slap your knees. Yee-ha, slap your knees. In, out, in, out, in, out, in. Airplane, tap, tap, tap. Count to 5. 1, 2, 3, 4, 5. Bobby, that was a strong finish, I must say. I think we are all ready for the ultimate level 3. Are we ready? Yeah! Was that me or I didn't hear anything? Are we ready? Yeah! Woo-hoo! Level 3, music on, let's go! Here we go. Heel, toe, march to the side. Heel, toe, to the other side. And ha, slap your knees. Yeah, slap your knees. In, out, in, out, in, out. Airplane. Tap, tap, tap. Count. 1, 2, 3, 4, 5. Woohoo! Give yourselves a round of applause. That was absolutely incredible. Such an amazing energy to get us ready for a fun-fueled National Numeracy Day. What did you think, Jess and Bobby? Because you were looking very good.
Wow, Katja, that was awesome. I can totally see how breaking down the steps into smaller, bite-sized chunks can really help you feel more confident. That's just like solving a maths problem. It's so important that we take our time, learn at our own pace, and remember that it's okay to make mistakes, whether you're dancing, like Katja, or using maths. Now we're all warmed up, are we ready to start on our mission to space? William Davis, are you ready? Yeah! They're definitely ready. I'm joined today by a very special guest, space expert Robert Massey from the Astronomical Society. Welcome, Robert.
It's a huge pleasure to be here, and I'm very excited about National Numeracy Day.
Yeah, and thank you so much for joining us. We're also joined by my fellow National Numeracy Ambassador, Jessica Gajan, who's an aerospace engineer.
I'm really excited to be here too. It's National Numeracy Day, everybody. Woohoo!
Okay, so before we answer some questions from the audience, I wanted to kick off things with a few questions of my own. So, Robert, can you tell us about some of the amazing ways that we use numbers in space?
You know, space is, we understand space through numbers, and some really big numbers, but they shouldn't be too daunting. So, you know, there are millions and millions of galaxies, and each one of those has millions and millions of stars in it. And if you want a local-ish example, you could fit 1 million Earths inside the sun. So the sun is really quite big.
That's really interesting. So, Jess, can you tell me your favorite numbers in space fact?
My favorite numbers in space fact is that astronauts actually grow in space because of microgravity. So the engineers and the scientists on the ground have to manufacture their spacesuits and their space seats to be adjustable to take this into account.
Wow, thanks, Jess. I'm definitely heading to space for the height edition. So when we think about astronauts and rockets, we might think that all numbers in space are really complicated. But maybe some of the numbers we find in space are more familiar than we think. So, Robert, what are some of the ways that numbers are used in space that we might recognize?
Yeah, I mean, you think really big numbers, but there are small ones, right? There are 8 planets in the solar system, so we could count all the planets on our hands. You know, not that many. And the other thing I thought about was, look, if you go to orbit, space is not that far away. It's 400 kilometers, which is like driving from London to, say, North Yorkshire or Durham. So, you know, distances, we measure all those things. It's quite familiar, really.
And Jess, what about you?
I think that it's really interesting to think of a rocket. And if we think of a rocket, there's lots of different fuels in that rocket, and so we have to use percentages in order to figure out the ratio of the fuels we need in order for the rocket to launch.
That's great. It's so interesting to think that lots of the maths we do every day is actually maths we can use in space. That might be because we use maths every day in lots of different ways without realizing it. So thinking about that, are there any jobs that people might do when they're grown up? Things that we might not expect to be jobs in the space industry? Jess?
Absolutely, yes. So there's lots of different types of engineers who are involved with building the spacecraft. But also astronauts, they have jobs before they're astronauts. Some of them are doctors, some of them are teachers, some of them are pilots. They all do lots of different jobs which require numbers.
Yeah, and look, scientists study the whole universe around us. They find out about space, and they do that in some amazing places. And they go to places like the Antarctic or the Arctic to look at the Northern Lights, if anybody saw that last weekend. They go to places like Hawaii because there are observatories on top. They don't go just for the beach. They go for the work there as well. And also, there are lots of things you can do alongside that. You don't have to go into space to work in space. So, you know, if you're a teacher, for example, you could be telling kids about space, or you could be coming out on days like this and infusing the world about it as well. And I think there's a brilliant things to do.
Thank you, Robert. So when we think about it, there are so many different kinds of jobs that we could do when we're older, whether it's in art and design, sports and fitness, or interest in tech. Now, it would be great to hear some questions from the audience. So if you're following along online, pop your questions in the comments or chat for us. So while we wait for those to come through, let's do something a little bit fun. So can you tell me your favorite space-themed joke, Jess?
I absolutely can. What do astronauts listen to aboard the space shuttle? Neptunes.
I actually do like that. Okay, I've got one for people watching along a line. Why did the astronaut wake up in the middle of the night? She heard a big bang. Okay, enough of the bad jokes. Let's hear some audience questions. First up, we have a question from Class 20 at Orleans Primary School in Twickenham. They've asked, are there any stars bigger than the sun?
Yeah, the answer is definitely yes. You know, shout out to the kids in Twickenham. There really are. And a lot of stars you see in the sky in the night are bigger. So in the winter sky, Betelgeuse in Orion, you could fit many suns inside there. I think at least hundreds, maybe thousands. So there are some pretty huge stars out there.
Wow.
So here's a question that we've got as well. Engineering, why is it so important to a career in space?
Oh, it's really important because we actually make lots of advancements in space which can help us down here on Earth. So the astronauts actually spend a lot of time doing different science experiments. Some of those are related to medicine, some of those are related to plants, and it's really important that we do these because then they help us improve human life on Earth. So it's really, really important.
Okay, another question about the moon. Is the moon really made of cheese? No, I was asking, Why are we planning on going back to the moon again? We've done it before.
Yeah, the answer is that we went there a long time ago. So the last astronaut stepped off the moon in 1972. So it's been more than 50 years since we were last there. So we study it with space probes. We sent robots there, but there's no substitute for sending people there and actually being able to walk around and pick up interesting rocks or drill into the surface. You know, there might be water under the surface we can access. We might be able to build a base and actually study the wider universe there as well. So people are really interested in going back. And I think there's likely to be a mission around the moon next year in 2025. And a couple of years after that, we'd expect to see people walking on the surface again.
Okay, could be you, Jess.
It could be me. It could be me.
So actually, one of the questions is about how did you end up being fascinated by space? Because you're like a Miss UK, traveling around the world representing our country. And people wouldn't expect you to be a space engineer, aerospace engineer. So how did that come about?
I have always been fascinated with science and maths and space. I think it's so cool, and it's something which is so current, and we're always going to be researching about. I think it's really interesting to learn how rockets work and how aeroplanes work, and I always just wanted to study that.
Wonderful. Another question is about the planets. Do you think that we'd ever colonize other planets in our lifetime?
Oh, it's a really hard question. Everybody talks about going to Mars, but it's really difficult. Now, we could do it. We could send people there. It would take them about 2 years. It takes 6 months to get there. You'd probably have to spend about a year there and 6 months to come back. So it's a big deal. And it's quite dangerous. You know, you've got to make sure that your spacecraft survives things like radiation in space. You build a safe habitat. So I think we'll do it eventually. I don't know if it'll happen any time in the next few decades. It might be towards the end of the century. So hopefully the kids watching this will get to see it. I don't know whether I will or not. I'd really like to, because it would be an incredible thing to see.
So actually a question from year 1 at St. Lawrence School in Rowhedge. And they've asked, how far is it to space?
Well, so there's lots of definitions. So you can go about, I think it's about 100 kilometers up. So 60 miles up. And if you go that high, you're technically at the edge of space, and that's where it's too high for planes to fly. So we talk about needing rockets, and that sort of counts as space. But I think most people would say it's when you get into orbit and you go around the Earth, and that needs to be at least maybe 300 kilometers up, something like that. And then you go around the Earth and you don't fall down.
And how far is 300 kilometers? Imagine we're going from London.
Again, it's about sort of London to Manchester, that sort of distance. Not too far.
So I could get a train there for like 100.
You could, yeah, exactly. Yeah.
Okay. So we've got a question from Saxonham Primary School in Norwich. So one for both of you. So actually, like, how do you understand space through numbers? Why do numbers really help us?
Oh, space through numbers is because a lot of the things we do, we need to calculate. So everything that we're doing, whether it's calculating how to get from our planet to a different planet or sending a satellite far, far, far into deep space, we need to work out how we can get that satellite or that rocket where it needs to be based on the gravity of different planets. And this is where numbers come into it. Things are changing all of the time. And it's just really, really interesting.
Yeah, I mean, what she said, and I think, you know, and also, if we want to understand things, we've got to measure them.
Yes.
And so we need to understand how hot they are, how big they are, how massive they are, how many kilograms there are, how far away they are, all of those things. And that's why we need numbers. It helps us in our everyday life as well, obviously, you know, but we do the same things in space.
Yes.
So we're getting students really obsessed by the moon here. Someone wants to know how long would it take to get from the moon to Earth?
Well, the astronauts in the 1960s did it in about 3 days. So I think that sort of timescale is what you say. It's not that far. I mean, you go much, much faster than you ever do on Earth. You know, it's not an easy thing to do. And to give you a sense of scale, you could fit 40 Earths between the Earth, or 40 moons, rather, between the moon and the Earth. It's a long way off. But, you know, rockets, 3 days or so is about right.
We've got lots of astronomy questions coming here. Obviously, our audience are really fascinated by that. So people have heard of Buzz Lightyear from Toy Story. What does the word light year actually mean?
So a light year, it sounds like it's a unit of time. It sounds like it's a year. Actually, it's how far light travels in a year. And I'm scratching my head to get this right. I think it's about 10 trillion kilometers, so 10 million kilometers.
Yeah.
So a long way, much further than any other planets in our solar system are.
And Jess, from your perspective as an engineer, do you think over the next 10, 20 years, you know, like people talking about AI, is that going to change the way in which engineers think about space?
I think so, yes. I think so. I think it might help us speed some processes up, because a lot of the times the engineers are creating softwares and then we'll then be able to develop softwares which can develop themselves, which is a crazy concept, really. But yeah, I think AI will definitely help in our new space race.
Fascinating. So we've got Shazeen 6B Cranbrook Primary School, and they've asked, so what type of maths is used to launch rockets into space? What type of maths?
Ooh.
I mean, all of it, really.
All of it, yeah.
That's,
There's lots of different types of maths which goes up from algebra to
Yeah.
calculus to multivariable calculus. So there's lots of different types of maths which are involved, and it depends on exactly the point in the launch that you're at as well. So if you've broken out of Earth's atmosphere, you're then going to be doing orbital mechanics, which is
Okay.
all about using, again, the pull of Earth's gravity
yeah.
to then launch the I said aircraft then.
Yeah,
Spacecraft. The spacecraft to wherever it's going.
Yeah. We actually had a couple of quiz questions, some of these from the students. They're asking, which is the biggest planet in the solar
that's
system?
one
It'd be
for you.
embarrassing if I got that wrong, wouldn't it? Yeah, no, it's Jupiter. Jupiter is much bigger than the Earth, and you could fit about 1,300 Earths inside it. So huge.
1,300.
And you can
Wow.
see it in the sky quite easily. I think from around, well, if you get up very, very early in the morning, you could see it at the moment. Really in the autumn, it's really bright in the night sky.
And then the Great Red Spot, how big is that? Is that
Several Earths across. I mean, it's ridiculous in size. So,
Yeah.
but it's a huge storm, and we think it might have been this storm that's been running for 400 years or so,
Yeah.
because it seems to have been seen almost as soon as people had telescopes. So, a crazy thing, imagine a hurricane on that scale.
Wow.
And again, we also have some questions coming in about colonizing planets. That's again, people are really interested. So, would that be something that you would ever be interested in as like a aerospace engineer, if you were given the opportunity?
If I was given the opportunity, I would definitely go to space. I would love to go to space. But in terms of visiting another planet, I think I'd like a few people to go before me to, set up base.
Okay.
And then maybe I'll go.
Yeah, it's not necessary. It'd be quite a rough thing to do. You're going to have to build this base from scratch.
Yeah.
And it definitely won't be luxury accommodation
No.
for a while. It's really complicated. You want to protect the place you go to as well. You don't want to take Earth bugs there in case there's, say, life on Mars and they interfere with it. So it's a really hard thing to do. But I think we'll do it. But it won't be. Don't imagine a sort of science fiction luxury hotel. It's going to be really rough for the first few years.
Yeah.
So we've got some questions from a teacher, Miss Ritchie. She's asked, do we need to use time in space?
Well, definitely, because you need to keep track of where you are. You have to. One of the complicated things is which time you use. So, because you're no longer dependent on the rising and setting of the sun, so you've got to think about, well, do I line it up with, say, GMT or a time zone in the US or something like that? And I think they just do it. I can't remember what time they used on the space station, but there is an agreed one.
I think it's
Yeah.
GMT. I think it might
they
be
have to be on
GMT.
the same. They have to be on the same. But you need to keep track of time. You need to know when to go to bed, and get up again.
So this question is sort of for both of you. So Amina Essex Primary School, they've asked, so astronauts up there, do you think they use calculators or their minds to work out calculations?
Oh, I think that probably depends on what they're doing. So if they're doing a more complex science experiment, maybe they're using calculators. But I think day to day, they're probably just using their heads. What do you think?
I'm sure that's right. We all do it right. We sit there, and if it's a simple thing in our heads, like if we're adding up a shopping list or something, we want to sit there and think, oh, roughly it's that amount. So I imagine they use both. You don't always want to get out the calculator on your phone just to work out something simple. It's really nice to be able to do that.
So we asked about, would you go into space? St. Augustine's Farrar School class in Peterborough said, can children go into space?
I mean, theoretically, yes. I doubt they're going to any time. It's just, at the moment, it's just a bit risky. So,
Yeah.
it's not quite like getting into a plane. It's much, you wouldn't get into a plane, I think, it's 1 in 100 chance that something goes wrong. That's a really bad, those are not great odds. So kids, not yet. I think it would have to get a lot safer for us to go up there more routinely. And that day might come, but it might be decades away, yeah. That's up to the engineers.
Okay.
People like Jess, I guess. So.
So actually, a question then for the engineers. Do you think they would have schools in space in the future then?
Oh, I think that sounds really cool, doesn't it?
Yeah.
Well, the way I think about things is science fiction becomes science fact. So years and years ago, we'd never gone to space. It seemed impossible, but actually we managed to do it. So in the future, I think we could maybe have schools in space.
That would be wouldn't
Yeah.
that be a brilliant trip out?
Yeah.
You can go to the zoo, yes, great, or you can go to space.
Yeah.
We got the Robert Massey or Jessica Gage in International High School. So we've got a couple more questions. From Nidhi Hogarth Primary Brentwood School, Year 5. Why are numbers so important to use? I guess not just space, but in general, why are numbers so important?
That they help us understand the world. They help us do everything, really. You know, if you know numbers, it's everything from being able to shop to knowing how big your house is to knowing how much wallpaper you need or how much paint or measuring the length of a bit of wood, all of those things, or measuring time, you know, seeing how long something is going to take or how far you drive. So for me, it's, yeah, absolutely vital. It's really good to be on top of your numbers.
And I think also sometimes we don't realize that we're using numbers. We're just doing it in our head and we're thinking about different things. So we're using numbers sometimes and not even realizing.
Okay, so I think this is the last question. So Cranbrook Primary School said, I think we might, they're asking lots of similar questions. What type of maths do you use to launch a rocket into space? This is going to be topical. So give me, what sort of maths do you think? Let's re-emphasize this one.
I would say lots of different types of maths.
Okay.
It's not just one type because it depends on the stage of where the rocket is, whether it's on the ground or whether it's mid-launch or whether it's after main engine cutoff or whether it's actually escaped Earth's atmosphere. So it depends on exactly where the rocket is, the kind of maths that we use.
Okay, so that was a great question. Do you have anything final to say on that?
Yeah, I mean, again, what she said, you know, you really look at the maths, how fast things are moving, where they are, all of those things depend on numbers.
Thank you. So that question was really topical. Was we have a rocket launch surprise for you? So Robert and Jess, thank you both so much. And thank you to everyone in the audience and online for watching and sharing your fantastic questions with us. If we didn't get around to asking or answering your question, why not find the answer for yourself? You could share it with us using hashtag National Numeracy Day. So what a brilliant way to start National Numeracy Day. I don't know about you, but I learned so many new things about how we use numbers in space, and I'm feeling inspired to give my number confidence and skills a boost. I hope you'll do the same today. So thank you to our amazing host, William Davis Primary School, and to our special guests from Numberblocks and the Royal Astronomical Society.
Fun does not stop here. We have so much more fantastic things going on for National Numeracy Day today. You can do some more dancing with me, or maybe Bobby has other ideas.
Oh yes, you can have a go at entering my awesome Number Heroes competition and win a prize for yourself and a whole bundle of prizes worth £1,000 for your nursery, school or community group.
That's right. Just search Numeracy Day to find out more and get involved.
Before we go, we've got one final surprise for you. Jess, are you ready?
Yes.
Katya, are you ready?
Yes!
Okay, our friends at Numberblocks have been working on something super exciting for National Numeracy Day. A few weeks ago, they invited me to build my very own number 10 rocket. And now, you can make your very own too. Head to the National Numeracy website to find the video and download sheet. Now, for the big surprise, the number 10 rocket I made is on standby, ready to be launched into space. How cool is that? Do you think we could all count down to the launch together?
Yes!
Great. Let's start from 10 and count backwards. Are you ready, William Davis Primary School? Are you ready, watching at school and home? You can join in too. Okay, let's go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
9, 8,
7, 6, 5,
4,
3,
2.
1. Blast off!
National Numeracy Day, Number Explorers.